We know that we're in, some say, once in a 1,200-year drought right now. We don't know when we're going to come out of this. If we don't do this kind of mapping, your average non-scientist or citizen isn't going to know what's going on unless we can bring it to them, to their living rooms. What we wanted to do was build our own systems that were going to be more deeply tuned to questions that we have about the status of our forests and how those are changing over time. Between 2011 and 2015, we built CAO3, which is a new, very high-tech airborne laboratory, including a new aircraft, that allows us to map massive areas at very, very high spatial resolution in 3D, and also lets us understand the chemical composition of, in this case, tree canopies in deeper detail than we've ever been able to do before. So we're sweeping the land in total 3D, like an MRI in a sense. We are on the frontier of new information that hasn't been available to managers, conservation people, policy decision makers.
This is Seki South. Can you just go to that area?
The different groups that are using different technologies will be key to connecting with other people who are doing forest cover analysis, and then our work on what's going on in the forest.
It's pretty shocking to sit here and watch the state dry out. GRACE stands for Gravity Recovery and Climate Experiment. It's a mission that is composed of 2 satellites, and they follow each other around. The system is designed to work like a scale in the sky. And with respect to water, what happens is this: as the satellites orbit around, they're following each other around, they're orbiting around the globe. When they encounter an area that has more water mass on the ground, that region exerts a greater gravitational tug on the satellites and pulls them down just a little bit closer to the Earth. When the satellites fly over a region like the Central Valley in California that is experiencing a tremendous amount of groundwater depletion or a lot of water loss because of a drought, then that region is exerting less of a gravitational tug on the 2 satellites, and the satellites float just a little bit higher. In each of these last 4 years, California has lost about 15 cubic kilometers of water, which is pretty sad, but this is exactly what's happening to our state. So GRACE kind of gives us an overall picture in a region, but work like Tom Painter's ASO will help us understand in much more detail, at far greater resolution, how much of what we're seeing is a snow signal.
The Airborne Snow Observatory is a combined spectrometer and laser altimeter. The spectrometer tells us how much sunlight is absorbed by the mountain snowpack, which is what controls snowmelt. About 90 to 95% of the energy that melts snow comes from absorbed sunlight. And then with the laser altimeter, we can tell how deep snow is. The plane flies on a weekly basis, which is about the amount of time needed to let the snowpack do its thing, make some change. It's timely information for the water managers to be able to know what the total volume is in the snowpack, how it's changed from last week. And so now we turn the products around in about 20 hours.
I think all of these technologies work together, and now it's up to our community and to the leaders of the science community to help us get together to paint one integrative picture. They're listening, they're watching, and they're actually very hungry for information. It keeps us motivated to produce as fast as we can.